Hello everyone, welcome to our channel where we explore the wonders of science and knowledge. In this video, we're going to take a look at the top 10 most important scientific discoveries in history. Fasten your seatbelts and let's go. Number 10, Theory of Relativity. Starting off our list at number 10 is the theory of relativity, proposed by Albert Einstein in 1905 and 1915. This theory revolutionized our understanding of space and time, and laid the foundation for modern physics. The theory of relativity is a cornerstone of modern physics, proposed by Albert Einstein in the early 20th century. There are two main components to the theory: special relativity and general relativity. Special relativity deals with the laws of physics in frames of reference that are moving relative to each other at constant speeds. One of the most famous implications of special relativity is the idea that the speed of light is constant, regardless of the motion of the observer or the source of the light. This led to the discovery of the equivalence of mass and energy, E equals mc squared, which has been used to develop nuclear energy. Number 9. Quantum mechanics. Next up at number 9 is the theory of quantum mechanics, which explains the behavior of matter and energy at the atomic and subatomic level. This theory has had profound implications in fields ranging from electronics to cryptography. Quantum mechanics is a fundamental theory in physics that describes the behavior of matter and energy at the smallest scales, such as atoms and subatomic particles. The theory was developed in the early 20th century by a number of physicists, including Max Planck, Albert Einstein, Niels Bohr, Werner Heisenberg, and Erwin Schrödinger. One of the key insights of quantum mechanics is that the behavior of particles at the quantum level is inherently probabilistic, meaning that it is impossible to precisely predict the outcomes of certain experiments. Number 8. DNA structure. Moving on to number 8, we have the discovery of DNA structure by James Watson and Francis Crick in 1953. This discovery revolutionized our understanding of biology and genetics, and has led to numerous practical applications in medicine and agriculture. The discovery of the structure of DNA by James Watson and Francis Crick in 1953 is one of the most important scientific breakthroughs of the 20th century. DNA, or deoxyribonucleic acid, is the genetic material that contains the instructions for the development and function of all living organisms. The structure of DNA is a double helix, composed of two strands of nucleotides, the building blocks of DNA, twisted around each other. The nucleotides are composed of a sugar, a phosphate group, and a nitrogenous base, adenine, thymine, guanine, or cytosine. The two strands are held together by hydrogen bonds between the nitrogenous bases. Adenine pairs with thymine, and guanine pairs with cytosine. Number 7. Universal gravitation. At number 7 is the universal law of gravitation, proposed by Sir Isaac Newton in 1687. This law explains the force of gravity between objects and has been used to predict the motion of planets and stars. The theory of universal gravitation, developed by Sir Isaac Newton in the late 17th century, is one of the most fundamental theories in physics. The theory states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In other words, the force of gravity between two objects increases as their masses increase and decreases as the distance between them increases. This theory explains why the planets in our solar system orbit around the Sun and why objects fall to the ground when dropped. Number 6. Cell theory. Coming in at number 6 is the cell theory, which states that all living things are composed of cells. This theory was proposed by Robert Hooke, Antony van Leeuwenhoek, and Matthias Schleiden in the 17th and 18th centuries, and laid the foundation for modern biology. Cell theory is the scientific theory that all living organisms are composed of one or more cells, which are the basic units of life. The theory was developed in the mid-19th century by a number of scientists, including Matthias Jacob Schleiden, Theodor Schwann, and Rudolf Virchow. According to the cell theory, all living things are made up of one or more cells, and all cells come from pre-existing cells. In addition, cells are the basic structural and functional units of life, carrying out all the essential processes necessary for the survival and reproduction of an organism. Number 5. Germ theory. Next up at number 5 is the germ theory of disease, proposed by Louis Pasteur and Robert Koch in the 19th century. This theory explains how microorganisms can cause diseases, and has led to significant improvements in public health. Germ theory is the scientific theory that many diseases are caused by the presence of microorganisms within the body. This theory was first proposed in the 19th century by Louis Pasteur and Robert Koch and has been instrumental in the development of modern medicine and public health practices. Before the discovery of germ theory, many people believed that diseases were caused by supernatural or environmental factors, such as bad air or miasma. However, through their work with microorganisms, Pasteur and Koch were able to demonstrate that specific bacteria and viruses were responsible for diseases such as cholera, tuberculosis, and smallpox. Number 4. Atomic theory. At number 4 is the atomic theory, which explains that matter is composed of atoms. This theory was proposed by John Dalton in the early 19th century, and has led to numerous practical applications in fields such as chemistry and material science. Atomic theory is the scientific theory that matter is composed of small, indivisible particles called atoms. This theory was first proposed in the 19th century by John Dalton and has since been refined and expanded upon by many scientists. According to atomic theory, all matter is made up of atoms, which are themselves made up of even smaller particles such as protons, neutrons, and electrons. The arrangement and behavior of these particles determine the properties of the matter they make up, such as its chemical reactivity, melting point, and electrical conductivity. The development of atomic theory has been instrumental in the fields of chemistry and physics, providing a framework for understanding the behavior of matter at the molecular level. It has also led to many important technological innovations, such as the development of nuclear power and the use of radioactive isotopes in medicine. Number 3. Heliocentric model. Moving on to number 3, we have the heliocentric model of the solar system, proposed by Nicholas Copernicus in the 16th century. This model placed the Sun at the center of the solar system and challenged the traditional geocentric model of the universe. The heliocentric model is a scientific theory that the Sun is the center of the solar system, and the planets revolve around it in elliptical orbits. This theory was first proposed by the ancient Greek astronomer Aristarchus in the 3rd century BC, but it was not widely accepted until the 16th and 17th centuries when scientists like Copernicus, Galileo, and Kepler provided more detailed observations and calculations. Number 2. Electricity. At number 2 is the discovery of electricity, which has had numerous practical applications in fields such as energy, communications, and transportation. This discovery was made by several scientists over the course of several centuries, including Benjamin Franklin, Alessandro Volta, and Michael Faraday. Electricity is a form of energy resulting from the flow of charged particles, such as electrons or ions. It has been known to humans for thousands of years, but it was only in the 18th and 19th centuries that scientists began to understand it better and make practical use of it. One of the key figures in the study of electricity was Benjamin Franklin, who famously flew a kite in a thunderstorm to demonstrate that lightning was a form of electricity. Other notable scientists in the field include Michael Faraday and James Clerk Maxwell, who made important discoveries about the nature of electrical and magnetic fields. Number 1. Evolution. And finally, at the top of our list at number 1 is the theory of evolution, proposed by Charles Darwin in 1859. This theory explains how species change over time through the process of natural selection, and has revolutionized our understanding of biology and the natural world. Evolution is the process by which different species of living organisms have developed and diversified over time, driven by natural selection and genetic mutation. It is widely regarded as the most important scientific discovery in history, as it has fundamentally changed our understanding of the natural world and our place in it. So there you have it, the top 10 most important scientific discoveries in history. Which one is your favorite? Let us know in the comments below. And don't forget to subscribe to our channel for more fascinating content on science and knowledge. Thank you for watching.